welcome to another lecture. So this one, to kind of help us jumpstart the Zoom sessions, this is a small exercise I want you to do. So this is a mini lecture about decision tree. Here we have a picture of two cities. We have one on the left is San Francisco, and on the right we have New York City. So if I'm asking you to say, well, I have a house, and I'm trying to ask you whether it is a San Francisco house or a New York house, how would you know? What kind of information you're gonna need? So pause a little bit there and think about all the information that you might need for. Okay, so things I can provide for you is the number of beds, number of baths, the number of square feet, the square price per square feet, for example, right? Elevation could be one, right? And you know, um, year built, for example. So those are basics information. What sets these cities apart? So that is the type of things that decision tree can help us to decide. The good things about decision tree is that it's quite easy to understand the mechanism behind, and it is one of the greatest way to kind of get you started in computational methods. So I'm providing you with the data here, right? You can see that number of bats, right? The price, the year built, the square feet, the price per square feet, the elevation, and we have a dummy variable called in SF or not. So with one represent this is a house in SF, zero it is a house in New York. And here's a link that you can go and then look at the data. So decision tree anatomy is very straightforward. We have a decision node, and within decision node, you're going to have two different answers. So, for example, here we're talking about the is it a suicide bomber or not, right? So, the first question will be, well, is the car itself single occupants? If you say no, right, and then it becomes, well, that will be a civilian. If you say yes, then you have to answer to a different decision that is coming down the stream, right? So you have another decision point called is the car approaching at high speed, and yes, and it does become a suicide bomber. And if it's no, then you say, well, this is a match between intelligence formation. If it's a no, then the civilian. If it's yes, the suicide bomber. It's a very basic decision tree. So the end results we're gonna leave, and the questions we're gonna ask called decision nodes, and the branches we're gonna come out. Those are decisions, answers. And the branch coming out, we call it decision answers. So if you take a look at this visual intro machine learning, right, you can understand a little bit more about the mechanism behind the machine learning algorithms called decision trees. It's a great visual, and I hope you are enjoying it. Now, come on to exercise, right? So we're going to create our decision tree based on these questions. So what I need you to do is we're going to ask 15 people 5 different questions here, and we're going to record the answer in the sheets that we're going to share with you. Question number 1 is that you ask a 15 person, do you prefer outdoor or indoor? Question number 2, do you prefer wearing shoes or flip-flop? Question number 3, you're wearing shirts, or you're buttoning up or buttoning down? Number 4, you prefer sunny or rainy weather? And the final questions, right, number 5, do you prefer a sweater or a jacket? And this would be our target feature, right? So what we're saying that I'm going to ask you 4 questions on top, how funky it might be. Those 4 questions will be the decisions points and decision questions that we are going to predict whether you are a jacket or a sweater person. Okay, the example is going to look something like this, right? On the left, you're going to have people, names, right? And here are 4 different questions that's kind of slightly different than ours. But here we got indoor, outdoor, shoe, flip flop, right? Are you a heat or a cool person? You like April or September, right? And the question's outcome was sunny or rainy, so you would just change it a little bit. But the same idea, comes. So basically, what I want you to do is we got 15 people that can answer these questions for you, and you're going to give us the data looking something like this. Okay, so here is the handout. I think you should be able to download this one, right? And then please go ahead and get 15 people to answer the question for you. So then we're gonna use that target and we're gonna create a decision tree. Now, what we're going to do is we're going to split our decision trees. Uh, Now, what we're going to do is we are going to split our 15 into a train and test set, right? So we got the first 12 people to train the tree. So then we're going to choose the largest application between the sweater and jacket. That's the first question. Then we're going to split between those answers. For example, if questions number one, and outdoor is one answer and indoor is another. So we're going to build a decision tree. We're going to create another second layer. We're going to choose another questions. It's going to be a different question on each of the split on layer number one. Then after the second layer, that's it. We are going to end. We're going to have the answer for the leaves there, right? And then we're going to say, well, if there are a majority of one class, it is a sweater. The majority of the other class is called jacket. Say it again, number 4. So after the second layer, how many answers gonna have? After the second layer at the end, we are going to use the results as part of creating the leaf. So we have 2 out of 3 that say sweater, then the answer of that split of that leaf be sweater. So we're going to calculate this for the training. So see how many out of 12 people, how many correct cases, which we can predict. And then we're going to calculate the tree for testing. So we got to get the last 3 people that you didn't use to build the tree, right? Going through the questions that they're going to have to see how many correct cases you can predict, right? So this is an example that on our decision tree. So for example, in here, then we have one question, indoor or outdoor, right? And if the person, the answer number 1 called indoor, then we have a rainy group and everybody there will be rainy. And then there's no second layer question. And that could happen too. If not, you can ask another question. You make another predictions in the second layer on the left side. Now, the first question say indoor, outdoor. The answer number 2 is outdoor. Then on the second layer question, you ask another question called, well, are you an April or September person? If it's an April person and you're an outdoor, then you are sunny, a sunny person. Okay. And if you are outdoor and you are in September, then you are 50-50 on sunny and rainy. So the results, what we're going to have here is 8 out of 10 person that in this example that has are correctly identified is 80%, which is great, right? And the model is saying, well, if I see it can explain 80% of the people of the data provided. However, the last 3 that we hold out, we didn't say that the models was created for, I only shows you that we have a 33, right? 1 out of 3 correct. So this kind of shows you the difference between the accuracy when you're creating the training and creating the testings. So I hope the example can give you the sense of what is the tree is all about. And here is to create the tree, that you can try to provide, for our class when we meet. And when you finish, right, please share the results on the Google Docs, and we can provide, and then please share the results in a Google Doc, and we can review it during the class. So the gist of decision tree here is that we're going to start with all the data points one group. We're going to find the best split that separate these outcome. Then we're going to divide further and further and further to make sure that they separate between the outcome and the best. We are continue until all the group are too small or sufficient or pure, what have you, in order to make the trees 100%. And that is the gist of the algorithms called decision tree. So I hope that you have a good time creating the trees, and I'll see you in the classroom. Have a good one. Bye-bye.